Imagine a massive saturation strike in the Pacific. Hundreds of Chinese drones and dozens of DF-21D missiles are launched simultaneously toward the fleet. Instantly, the Ghost Fleet detects the surge, triggering a localized microwave kill zone that drops the drone swarm into the ocean. High above, F-35s, refueled and ready, begin picking off the main missile wave with their shield lasers. At the same time, the fleet's destroyers unleash a hail of HVP slugs at Mach 5, shredding what's left of the attack in midair. Any final leakers are vaporized by the Helios at 186,000 miles per second. When the smoke clears, a $500 million attack has been defeated for a front cost of less than $5 million in electricity and tungsten. The US Navy didn't just win the battle, they just bankrupted the enemy without even turning on their main radars. The front cost of attacking America just hit zero. Today we're exposing the secret weapons that just turned the world's most feared missiles into expensive scrap metal. The missile wall. If the aircraft carrier is the heart of the fleet, the SM-6 is its sharpened teeth. But don't think of this as just another missile. This is a 3,300-pound stratospheric hunter, featuring a massive 21-inch rocket motor. This booster isn't just for show. It's what allows the SM-6 to punch through the atmosphere to altitudes exceeding 110,000 feet, moving at hypersonic speeds to chase down targets like the Russian MiG-41 or Chinese glide vehicles before they even enter their terminal dive. But a hunter is nothing without its eyes. Enter the SPY-6. This isn't just a radar, it's a massive upgrade in physics. While the older SPY-1 systems used a single transmitter, the SPY-6 uses radar modular assemblies, individual 2-foot cubes that act as independent radars. The result? The SPY-6 is 30 times more sensitive than its predecessor and provides twice the range. It can detect a target with the radar cross-section of a golf ball from over 200 miles away. Even more impressive is its processing power. It can track over 30 times more targets simultaneously than the older Aegis systems, allowing a single destroyer to manage a chaotic swarm of hundreds of incoming threats. The real black budget magic, however, happens through the NIFC network. In a high-stakes clash, a destroyer doesn't even need to see the enemy. An F-35 flying 200 miles ahead can spot a target, lock on, and hand off the firing solution to a ship over the horizon. The destroyer launches the SM-6, and the F-35 guides it to the kill via an encrypted data link. Electromagnetic death. In 2021, the world thought the US Navy had failed. After 15 years and $500 million, they shelved the electromagnetic railgun, claiming the barrels melted after just a few dozen shots. But the Pentagon didn't kill the project, they stripped it for parts. They took the magic bullet of the hypervelocity projectile and pulled off the greatest tactical pivot in naval history. By stripping the HVP of its electromagnetic barrel and stuffing it into the standard Mk-45 5-inch powder guns found on over 80 US destroyers, the Navy achieved the impossible. Using a specialized 4-piece sabot to capture the explosive energy of a traditional charge, they are now launching these 28-pound tungsten darts at a muzzle velocity of Mach 5+. The math here is a nightmare for an enemy. A single SM-6 missile costs $4.3 million. A single HVP round? Roughly $85,000. That is a 50-to-1 cost advantage. During a massive 2024 live fire exercise, the Navy proved these rounds could intercept cruise missile surrogates with pinpoint accuracy. But the real disruption is the magazine capacity. A standard Arleigh Burke destroyer has 96 VLS cells for missiles. Once they're gone, the ship is a sitting duck. However, that same ship can carry over 600 HVP rounds in its standard magazine. This effectively turns every ship in the fleet into a hypersonic machine gun, capable of firing 16 to 20 rounds per minute. At a range of 200 miles, these rounds don't need explosives. Because they move at over 5,000 feet per second, the kinetic energy upon impact is equivalent to being hit by a freight train, condensed into a 2-inch point. You can't jam a solid block of tungsten, and at Mach 5, you can't outrun it. The Sentinel, F-35, and the Shield Laser. While the world views the F-35 Lightning as a stealth fighter, the US Navy is transforming it into a flying high-energy node. This is the Sentinel, and its mission is to ensure no missile, no matter how fast, ever touches the carrier. The heart of this defensive leap is the Shield Pod, Self-Protect High-Energy Laser Demonstrator. We are talking about a compact podded laser system that doesn't just jam incoming missiles, it destroys them at the speed of light. In 2025 to 2026, the Navy integrated these pods with the F-35's Block 4 update. This technical refresh provides 25 times more computing power than previous versions, allowing the jet to run the complex algorithms required to track a Mach 3 missile and hold a laser beam on a single 1-inch spot until it detonates. But the Block 4 isn't just about defensive lasers, it's about massive offensive lethality. Thanks to the Sidekick internal rack upgrade, the F-35 can now carry 6 internal AIM 120 AMRAAM missiles instead of 4. increasing its stealthy air-to-air capacity by 50%. For long-range strikes, it utilizes the AIM-260 JATM, a secretive black-budget missile with a range estimated at over 120 miles, designed specifically to outrange the Chinese PL-15. For maritime dominance, the F-35 carries the AGM-158. This is a stealthy, autonomous anti-ship missile with a 1,000-pound blast fragmentation warhead and a range of 200-plus nautical miles. Because the F-35 acts as the eyes for the fleet, it can track up to 30 targets simultaneously from over 100 miles away using its APG-81 radar, handing off targeting data to the carrier strike group via the MADL data link. You aren't just fighting a jet, you're fighting a speed of light. In the modern Pacific, if you can't hit the Sentinel, you can't hit the carrier. Weaponized light, the directed energy suite. The star of the show is the high-energy laser with integrated optical dazzler and surveillance. Currently patrolling aboard the USS Preble, this 150-kilowatt weapon system is a triple threat. It functions as a long-range ISR sensor, an optical dazzler to blind enemy satellites, and a hard-kill weapon. The math is where it gets legendary. A single Helios shot costs exactly $1 in electricity. Compare that to a $2.1 million RIM 116 missile, or the $3,500 per second cost of firing a Phalanx CIWS. With the A-1B nuclear reactors on a Ford-class carrier, pumping out a staggering 300 megawatts of electrical potential, 3 times the capacity of the older Nimitz class. The carrier essentially has an unlimited magazine. As long as the core is hot, the ammo never runs out. But the Navy is pushing that tech into smaller, more aggressive packages. Enter the Directed Energy Maneuver Short-Range Air Defense. This is a 50-kilowatt short-range beast designed to solve the drone swarm problem. While 50 kilowatts sounds lower than Helios, it is focused into a beam roughly the size of a quarter. In recent 2024 testing, it successfully engaged and destroyed Group 1, 2, and 3 UAS. That's everything from hand-launched drones to 1,300-pound strike UAVs, at ranges of up to 5 miles. Because it's modular, the Navy is now testing these on unmanned surface vessels to create a 360-degree laser moat around the carrier. And then there is the black budget nightmare, the pulsed energy projectile. Unlike a continuous wave laser that heats a target, the PEP fires an ultra-short megawatt-class pulse lasting only a fraction of a second. This pulse doesn't burn. It creates a localized plasma burst on the surface of the target. This plasma creates an electromagnetic pulse that fries internal circuits instantly and generates a kinetic shockwave equivalent to being hit by a flashbang grenade at point-blank range. It is a no-go zone that moves at 186,000 miles per second. In the era of weaponized light, the enemy's speed becomes a moot point, because you simply cannot outrun the sun. Drone Warfare 2.0, the robotic frontier. Leading the charge is the M-25 Stingray, a $150 million stealth drone that has fundamentally broken the carrier's limitations. By offloading 15,000 pounds of fuel to the F-35 fleet mid-flight, the Stingray effectively doubles the carrier's strike range to over 1,000 miles. But its true value is economic. It frees up manned fighters for combat, turning every carrier deck into an all-day strike platform. China, however, isn't sitting still. They are betting heavily on loyal wingman concepts like the GJ-11 Sharp Sword, a stealthy UCAV designed to penetrate the carrier's outer defenses. But while China is focusing on the stealth strike of individual drones, the US is focusing on the combat cloud. Enter the Ghost Fleet Overlord, autonomous ships that act as forward-deployed sensor nodes and missile sponges. These unmanned vessels push hundreds of miles ahead of the carrier, using high-power microwave weapons to fry incoming Chinese drone swarms before they even see the fleet. The gap here is in the software. While Chinese drones like the Winglong 3 are lethal, the US Navy's Collaborative Combat Aircraft program is building drones that can think for themselves, sharing data across the entire fleet in milliseconds. In this new robotic frontier, the winner isn't the side with the most drones. It's the side with the most intelligent network. The US is betting that a single self-thinking machine is worth more than 1,000 dumb ones. China launches a $5 million missile. The US answers with $5 worth of laser and metal. That's not balanced, that's a warning. These weapons don't just intercept, they rewrite the rules mid-flight. Hit subscribe, and we'll keep showing you the tech that flips the battlefield before it even starts.